Hello students! Today we're going to have a pretty short discussion, a reminder of the types of research methods that we've learned about throughout this semester. So it's going to be pretty quick. I just want to briefly remind you of the different research methods that we learned because it'll be important come the exam time, as well as just to remind you the different methods, how they're different, how they're similar, now that you have a pretty good handle on them, especially since some of the ones you haven't heard about in a couple months actually. So let's talk about the types of research that we do in psychology. One is observation. So this is making observations of things. Naturalistic observations is one example of that. That would be trying to get as much of a natural example as you possibly could. You're trying not to change behaviors of people. You could do a naturalistic observation of children at recess, or you could do a naturalistic observation of the behavior of college students at Starbucks and hopefully not change their behaviors when you're observing them in that setting. You can also do observations in laboratory settings, so you can make a more contrived specific example, a little more focused. You've got control over some of the variables. So you might be looking for specific kinds of behaviors, like specific helping behaviors, or if someone is doing an antisocial thing. So you're playing a game. How many times do people help versus how many times do people steal in the game? So you're kind of contriving something but still making observations. Your observations might just be qualitative data, just describing things in a lot of detail, or you might be using quantitative data as well, like counting how many times things happen. So putting a number to things would be quantitative. So another example of research methods are surveys. We mentioned them quite a few times because they're pretty widely used in psychology. It's an easy way to get at how people feel, understand, and think and behave. So with that, there are validity concerns with all these methods, but as long as you make a valid survey that's getting at the actual thing you want it to, a survey can be a really useful tool to get data. It's also really easy to use that data in statistical analyses. Interviews are another way to get information. Again, an interview could be qualitative, so just getting a bunch of information from someone, or it could be quantitative. You're trying to figure out exactly how many times they mention this thing, or how many family members they had. So it can be qualitative, it can be quantitative. It's often one-on-one. You can do group group interviews as well. Oftentimes you're going to get a lot more in-depth responses from an interview. A standardized test is in some ways similar to a survey. Usually it's some sort of uniform test. So the SAT is an example of something that's uniform. Basically everybody does the same tasks to try and compare scores against other people's scores. That's what the standardized means. It means it's standardized scores, so your score you can compare to someone else who did the SAT, or specific types of IQ tests are standardized. So that is what a standardized test is. You're doing specific tasks, and then your responses are compared to other people, and you kind of know where you score in relation to others. Is your SAT higher or lower than your friends? That kind of thing. Case study is usually qualitative, so but you can also do quantitative data in a case study. So it's a really super in-depth observation, again, of a single case. So you might have a really unusual disease that someone is experiencing. So you could get some quantitative data, like what's your temperature? So get their actual temperature assessment. What's their blood pressure? So those would be quantitative assessments. You could also get qualitative assessments. How are you feeling with this? How did this happen? So get qualitative data that way too. So a case study we often think of as an individual. It can be a bigger case. The big thing is it's just got to be around some unique feature. So this example that we gave was a bunch of children and early adolescents basically made their own club within their community. So they built their clubhouse, they organized it themselves, they choose their activities, what they're going to do in the community. And it's completely outside of any adults saying, hey, you should do this, or hey, here, this is a good idea, or any kind of adult supervision. The kids have this unique thing that they built a club all entirely in and of themselves. So that could be an example of a case, some unique feature. So an example of a school district doing something really different or unique could be a case study as well. So again, you can do qualitative or quantitative data with that. Physiological measures are the things that check things in our body. So you might use a physiological measure as part of your case study. The blood pressure, for example, is a physiological measure. fMRIs, heart rates, hormone levels, temperature, blood pressure, all these kinds of things, how much you're sweating. So those kinds of things are physiological measures, what your body is doing. And some of them are related to aspects of psychology. So if you're feeling really anxious, how hard is your heart beating, as an example. So the different kinds of research designs that we really focused on were descriptive research, where you're just describing things, trying to get a big picture or a big understanding of what is happening here. Correlational looks for specific relationships between different kinds of things. So what's the relationship between heart rate, anxiety, and this new drug that we're testing? Experimental research might be the one testing some specific new drug, right? So you're looking for manipulating a specific variable and seeing the outcomes. So again, descriptive, oftentimes you're going to be using things like observations, surveys, interviews, case studies, content analyses. I think I didn't include that, but content analyses is basically an analysis of documents, or it could be something like journals or documentary footage from a specific period of time to learn about what's happening, or what was happening at this specific time. So you're trying to describe what was happening around this phenomenon. Why did people do this thing at this time? Why did one kind of descriptive research, you could look at and do interviews, do surveys, do observations, even content analysis to try and figure out what happened for medical marijuana to become so prevalent across the US. Like, what was we'll describe the pattern of what happened, would be descriptive research. So correlational research looks at relationships between individual variables. Again, these can range in strength from -1 to +1. The negative positive tells us what direction that graph is, and as close as it is to 1 tells us how strong the relationship is. So if it's close to 0, it's a very weak relationship, even non-existent. Closer to 1, very strong relationship. So some examples here. This is a pretty strong negative correlation. You can see it's going this way. This could be any two variables. Maybe this is going back to my previous example, your anger around marijuana. So if you are angry at marijuana, you have a high score. And if you're not, you're a low score. So maybe this is time. So over time, people's scores are lower. Maybe not a perfect example of a negative correlation. Any two variables, let's just make up two random variables. Let's say this one is happiness and this one is kittens in the room. All right, so for people who have really high happiness, they've got like 1 or 2 kittens in the room. People with really low happiness, they have like 5 kittens in the room. So these are related variables. Kittens and happiness are related. It looks like, it suggests from this that there is a relationship between kittens and happiness, and it appears that fewer kittens leads to more happiness versus more kittens leads to less happiness. Well, leads is a bad word. So it appears that having more kittens, people respond that they are less happy. Less kittens, people respond that they are more happy. So that would be an example of a negative correlation. Again, I literally just made it up. I'm not sure if that's actually the relationship that it would exist, but I imagine once you get too many kittens in a room, it might get a little crazy. So you might be pretty happy and then maybe a little too stressed out and anxious to be happy about all the kittens at a certain point. Let's use it for this example here. This is a strong positive correlation. You see it's a really narrow, skinny line versus this one is a little bit broader. So there's a strong positive correlation here. It would probably be something like a positive R.85 or higher, so very close to positive 1.00. And let's say again, this is a happiness score and this is a kittens. So the people who are the most happy were the ones who had the most kittens in their room. People who were least happy were the people who had the fewest kittens in the room, and people who had medium happiness had medium level kittens in their room. So that would be a strong positive correlation. This one, you can't really see that there's, or you can tell there's not really a clear line up or down. So there's really no correlation between these two variables. So it doesn't really matter about the kittens in the room in this example. So again, this is happiness, this is kittens in the room. Some people with 1 kitten in the room or 0 kittens in the room were very happy. Some people with 1 or 0 kittens in the room were very unhappy. Some people with 7 kittens in the room were very happy. Some people with 7 kittens in the room were very unhappy. So there's not really a relationship here between kittens and happiness. So that's what correlations are looking for. We can also use correlations in multiple regressions for trying to look at patterns between multiple different kinds of variables and even predict things. So I might, if I had a couple graphs of happiness for kittens and happiness for dogs separately as studies, I could maybe put those together in a multiple regression and predict how happy you would be with kittens and dogs in a room. It might come out not to be the case because again this is correlational, this is not causal data, but it might give us some ideas about what to expect. So that's a big point. Correlation does not mean causation. These examples I gave might be kind of causal, but most correlations are not causal. So for example, we talked about the ice cream and murders example, that those are correlated. More ice creams are sold, and when more ice creams are sold, we also observe more murders are happening, but it's not the ice creams causing the murders. It's not the murders causing the ice cream, right? So there's another variable there that leads to both these relationships. So here's some examples of actual real data to see what correlations really look like. So this is this is purpose in life, this is heroism, and this is social heroism. So this is actually a subsection of this measure. So social heroism and heroism, about half of these questions are combined in this. So they should be very highly correlated because literally half of the questions are the same. And then we see here the graph between heroism and social heroism. It's a very strong positive correlation. The number is R equals 0.89. So that's a very strong positive correlation, and this is what it really looks like. So this person right here, so I won't move, so I'm going to highlight them. This person that I'm pointing to scored about, I'm just trying to measure on my screen, on social heroism they scored about a 5, on total heroism they scored about a 3. So you see they're a little outside the, on the outside edges of this distribution versus this person right there in the cluster, like closer to the cluster. Maybe let's just use the red dot in the middle. So this person in the very middle of the distribution scored a 4 on social heroism and scored a 4 on actual heroism. So clearly these should be very related because it's half of the questions are the same. So there should be a really strong positive correlation there, and this just gives you an idea of what an actual strong positive correlation looks like. This is the actual data from actual people, but we can also look at heroism correlated to purpose. So heroism, the full scale, correlated to purpose in life. It did find a moderate positive correlation, the R of 0.33. So this isn't super strong, and you can see the computer did find a line of best fit, but it's not nearly as clear as this one, right? It's clearly, this is a very straight line. The computer says, yep, there is obviously some more pattern. It drew this circle around the data right there. There is a bigger pattern of a lot of people clustered right here, but we have some people scoring very high on heroism. So this person scored almost a 7 on heroism, so they're very likely to act heroically, and they are about a, what is that, about a 2.5 on purpose. So not super strong purpose in life. This person scored a 2 on heroism, so pretty unlikely to do something heroic, and they scored about the same, about a 2.5 on purpose. So this person scored about a 7 on both. This person here scored about a 1 on both heroism and purpose in life, versus this person scored very low, a 1 on heroism, but they scored about a 6 on purpose. So you can see the pattern of results here clearly gives us a little bit of a relationship, but not nearly as strong as this one. So hopefully this gives you a sense as you read your research papers, what does it actually mean when it says a correlation of 0.33 or zero point 0.4 or zero point 0.8. So something like 0.8, it's a very clear relationship. 0.3 is still a clear relationship, but it's definitely not as strong as this relationship. All right, and we'll ignore this one right now because it's really similar to the 0.3. All right, here are a couple other examples. Social desirability. So social desirability and heroism, I was hoping that they would not be correlated because you don't want people answering your heroism scale in a socially desirable way. And so this person, this person, this person, this person, they all answered in a socially desirable way. So they were trying to make themselves look socially desirable. This person, this person, this person, this person, this person, all answered in a way that was not socially desirable. But we can see that there's a whole range. So the computer found this line of best fit, and there's a cluster kind of in the middle there, but the correlation is very close to 0. So R equals 0.06. So very, very low, essentially no relationship between these two variables. So which is what I was hoping for between those two things. So hopefully that gives you a better sense of what you're actually looking for with correlations, with actual data. Now, moving on to experiments. So again, this is kind of a quick description because we've talked about experiments recently. Experiments use randomization. They can determine cause here, and you look at least two variables. So you manipulate one variable and see if it changes the other variable. So in our case, we have two groups. We randomly put students in the quiet room or the experimental room that's loud. We give them all a test, and we see who does worse, the people in the quiet room or the people who are in the loud room. So our two variables are loudness, so one is not loud and one is loud, and then the other variable is test score. So what's their test score compared to their test score? If there's a difference, we can be pretty sure that our loudness of the room caused that change, right? So an independent variable is the one that we manipulate. In our example here of the room, we are manipulating the loudness. We're changing the loudness to see if it will affect the dependent variable. So the dependent variable is dependent on the independent variable. So independent variable is also called IV, dependent variable is also called DV. So DV is also you might think of it as the final measured variable. So our test score is our dependent variable, is the thing that we want to see if it's changed because of the independent variable. So with experiments, the best thing to do is randomly put people in your groups. You want as big of a sample, so let's say you've got 700 people. I'm going to use an easier number. 600 people. You've got 600 people, you want them in equal groups, so you have a computer randomly put people into the groups, either group 1 or 2, right? The quiet room or the loud room. So those 600 people, now you have about 300 in one group, about 300 in another group. Because it's randomized, you might have like 330 in one group and what would that be, 270 in the other group. So it might be slightly different, but it'll be pretty close to equal in both groups, right? And the bigger your sample is, the better that randomization is. Because out of those 300 people in each group, you'll probably have some that are low SES, some that are high SES, some that are middle SES. You'll have some that are male, female. You might have some that are trans. You might have some people that are older, some people that are younger, some people that are of varying ethnicities. So the bigger you start your sample with, the better it is for that randomization. Also, some things might be more important than those demographic variables I mentioned. So maybe your knowledge of math, for our example of the quiet room, loud room, let's pretend it's a math test. So maybe some people in that 600 are just better at math, right? They're really, really great at math, and some people are really terrible at math. So we want those people randomly in both groups. We want about equal people in the quiet room and about equal people in the loud room that are good at math. Likewise, we want about equal people that are bad at math in the quiet room and the loud room. So that's why randomization is so important, because those other variables, like how good are you at math, we might not have time to measure those beforehand. You could intentionally measure those and then put people in different groups intentionally, but a good way to do it is just randomly put them through, because there might be variables that you don't know are going to affect. Maybe some of the people that are good at math have dyslexia, and so you want some people that are bad at math and dyslexic in both groups, or good at math and dyslexic in both groups, right? But you might not have even considered measuring for dyslexia. So random assignment really helps you control for all those other possible variables that might affect how well they can, say, read and do well on that math test. And that helps us be much more likely to say, yes, our loud room versus our quiet room made a change in test scores. All right, so the strength of the manipulation is important too. In our example, it was pretty simple. We had it was either on or off, so loud or quiet. You could also have a couple different levels of loudness. You could have quiet room, kind of loud room, very loud room. And you could check that. You would need, let's say we take those 600 participants, put 200 in each group, right? So if you want to see what works best for building muscle, you could give one, you could say, hey, you group, do these exercises for 4 weeks with no weights. You group, do these exercises with 10-pound weights. You group, do these exercises with 20-pound weights. See who builds the most muscle, right? So you've got a different strength of the manipulation. So other things that you can do to change the strength, you've got high, medium, or no treatment, intense treatment, moderate treatment, or a control group, a long treatment or shorter treatment, and a control group, right? So you could test those different things, changing the manipulation. I think that gives you a pattern of results. So we've recently talked about patterns of results. If you see that you get better and better with stronger and stronger manipulations, well, then you might want to find, well, what's the strongest manipulation, like the longest one, the most intense one, that causes the biggest change. Because at some point, for some interventions, the benefit outweighs the cost. Let's say you had people study. You said, okay, you group, you study 1 hour for the test. You group, you study 4 hours for the test. You group, you study 8 hours for the test. Which group is going to do better? My guess is you'll probably see on average the group that studied, let's say 4 hours, do better than the one that studied 1 hour, but probably the group that studied 8 hours isn't going to do much better than the group that studied 4 hours. They're probably going to be about the same, and then you can know, okay, so 8 hours is pretty intense. We don't have to recommend that, but somewhere around 4 hours we're pretty sure is the best. Makes the biggest change in your score. All right, so some types of experiments. So this is post-test only. The X basically means you've done the intervention. So one group gets an intervention and gets a post-test. Survey, test score, whatever it is. This group just gets the test. So this is our quiet room right here. This is our loud room right here. The treatment was the loud room. You could do a math test first for a pre-test, post-test control group design. So this group gets a math test, then they go in the loud room, they get another math test. This group gets a math test, they go to the quiet room and get another math test. So that's pre-test, post-test, and post-test only. So quasi-experiments are when you can't do one of those things. Maybe you can't randomly assign, or you can't manipulate the independent variable. You might be able to do a quasi-experiment. You can still do causal inferences, you can still get causal data. It's generally not as strong as a true experiment, but there are some really, really strong quasi-experiments. So for this, let's say we want to do a new treatment to help our child turn in homework. So we get a baseline. They are their own control group. This is like the pre-test period. We see that every few days they're turning in work, or like one piece of work. But then we start the next week, we start giving them a reward every day they turn in work. By the end of the week, they're turning in all their work, like all seven homework assignments would be ridiculous. But let's say that's what they're doing. But then the next week, we stop giving them rewards again. And we watch, and then we see this pattern of results. When we started the intervention, when we started doing the reward, their behavior changed, right? And then it went back when we removed that treatment. So that's a quasi-experiment. It's called a reversal design. We can do multiple baseline designs. We can say, okay, for math class, we will start a treatment after 3 days. So we get 3-day baseline. Then in science class, we'll start it after 1 week. In English class, we'll start it after a week and a half. And so you can try the same treatment in multiple ways and get multiple baselines. An interrupted time series design is the closest, and in some cases even better than a true experiment, because it's done in kind of the real world. So we talked about this example in the chapter on quasi-experiments. These were 2 places that had problems with garbage production, so they tried an intervention to decrease garbage production. So this was the one that got the intervention. So starting at this point, they stopped picking up garbage one day at a time, and they were hoping to see this line trend down because people didn't want to produce so much garbage and just keep it in their homes. Turns out, didn't work. This specific study showed that, well, it just made them take all the garbage the next day. It wasn't enough time to have an effect. So maybe they considered having them keep their garbage for 2 days instead, but then you've got a lot of sanitary concerns, so they probably didn't want to do that. Since that time, these countries have gotten a lot better about their garbage production, but it's a really great example of a time series design. Another thing you could do is, let's say a new law goes into effect. You can compare the places before and after the new law came into effect. Maybe this city didn't have that new law, so compare the similar cities. One had the new law changed, the other didn't. See if it actually changes, say, crime rates on that. So some other types of designs are longitudinal designs and cross-sectional designs. Cross-sectional is trying to get at developmental information. Today, I would study, let's say, 5-year-olds, 10-year-olds, 15-year-olds. So one point in time, I get this data, and I might be able to say, okay, it looks like from 5 to 10 to 15, you get better at your working memory. You can hold 8 pieces of information by the time you're 15 versus only 4 when you are 5. Humans actually can hold like about 5. If you remember our discussion at this point, but it's just an example. So this allows you to infer things about the development, but it's not as good as a longitudinal design. So for this, we would take those 5-year-olds and we'd follow them. We'd measure their working memory today. When they're 5, we'd measure them when they're 10, and we'd measure them when they're 15. And that's really great because it lets us see the change over time. It lets us see that development, because these groups with the cross-sectional design, they've experienced different things, right? The 15-year-olds, they were at a different time in school when COVID happened and the lockdowns happened, versus the 10-year-olds, they were at an earlier age in school when COVID happened. 5-year-olds might have not even been in school when COVID happened, right? So the history effects might affect things in a cross-sectional design versus longitudinal designs. Those 5-year-olds, they get the same things in the society around them at the same time. So usually these are difficult to do because 1, they take a long time. 2, they tend to be more expensive, but they are generally considered like the gold standard of seeing change over time. A way that you can do this is the sequential method. You put the cross-sectional and longitudinal together. So you've got the 5-year-olds and the 10-year-olds. You measure them today, but then you also follow them for the next 5 years. So then you've got the 5-year-olds from the time they were 5 to 10, the 10-year-olds from the time they were 10 to 15. So you're kind of combining them both. Has some of the limitations of both, but it gets rid of some of the limitations of both as well. So it's a really good tool. So here's a couple other examples of those. So a key point is that we may use multiple methods in any given study. We might use a case study that also uses an experiment within that case, or multiple methods in a series of studies to understand things. The experiments we might use have a pretest or a post-test. We might use a psychological measure of stress and a survey measure of many variables. Then follow up 1 month later and 3 months later. Now it's longitudinal. So I've done this actually, so done a pre-test and a post-test for a measure for a intervention of mindfulness. So tested it right immediately, see, yep, there was a change in how mindful they felt, how their stress decreased. Then we followed up a little bit later, so it wasn't quite a month, but we saw the decrease we saw the stress level go back to normal essentially pretty soon after. So we started with one type of study, we ended up being multiple types of studies. So experiment, longitudinal as well. So there are ways to put methods together to get at your answers better and have a really clear picture of what's happening. So that's why I wanted to talk about these different methods again, because 1, it's been a while since we've mentioned a few of them, and 2, so that you can have some ideas of how you might put these together in unique ways to answer the research questions that you're reading about in your papers, that you're thinking about in doing research, and how multiple methods together can really help us converge on any given answer. So use whatever methods and measures and combinations are best to answer your questions. Try to falsify your hypotheses. try to figure out the best way to do these tests. And sometimes it'll be a randomized control trial and pre-test, post-test experiment. Sometimes it'll be a case study. So sometimes it'll be both. So do the best methods to answer the questions, because the data is useful, but your methods are the most important thing first to get good data. All right, that is it for that little review of the types of research methods we've used. Obviously, there's more that we could discuss with each of them and did in those chapters, and there's some that we kind of really briefly skimmed, but those are the ones that I hope you take with you and understand and remember after you're done with this class.